Hi there, and in this video what I want to do is take a look at the book The Trial by Franz Kafka, and I want to analyse the text that's in that book. I want to have a look at things like what's the most frequent words that occur in the book, what are the most frequent, how do I visualise the most frequent words, what is the distribution over the words, and we're going to take a look at some of the code that's required in order to do that in this video. So to get started, let's look at the function I've got here. This is a simple function. It's just going to fetch text from this link, and that's the link to the Kafka book The Trial, which is defined as a text file. I'm using Python's requests library to send a GET request and getting the text from that, splitting out the 𝗬𝗏, it's got some boilerplate at the start and the end, splitting that out so we just get the text of the novel and then fetching that text. So if I execute this, it gives us back the text. So what we want to do now is define a few functions to clean the text up essentially. You can see it's very unclean. It's got all sorts of new line characters, it's got lots of punctuation. So what we're going to do is clean this up and replace the new lines and replace some of the punctuation. So I've got a couple of imports. I'm going to use the regular expression module and the string module. Now the first thing I want to do is replace the new lines. So I'm going to define so the new line character is the /r/n, and what we can do is use the string.replace method. We're passing in text to this function, and we want to use the string.replace method, and we're going to replace the new line character with a single space, and that's the first step. And with the new line characters removed, and what we're going to do next is remove the punctuation, and that can be done using the translate method, string.translate. What we do is pass what we call a translation table, and we can use the string.makeTrans function to create that translation table, and we want to translate all the string.punctuation into into nothing essentially. So that will remove the punctuation, and finally we want to use the RE module, and we want to subtract out all spaces when there's more than one space, and replace that with a single space. Now what this is going to do is actually, a lot of the times when we replace, we might replace certain characters, it might have more than one space. S+ here, /s+ in regular expression syntax means one or more, essentially one or more spaces, and replacing that with just a single space. That will get rid of like 2 spaces, 3 spaces, or any number of spaces, and replace them with a single space. So that allows us to normalize better. And finally I'm going to return that text, but I'm going to lowercase it, and I'm going to split out I'm going to strip the starting and ending spaces from the text. So once I've done that, I can look at the resulting text by calling preprocessed text and passing in the text that I got from the URL, and that will give us the trial. If I have a look at the text that I've got here, you see it's all lowercased. Every space has been replaced by a single space. All the new line characters are gone, punctuation's gone. So that's kind of what I want. And this is a very basic pre-processing function. We could do more advanced things like stemming, and we could lemmatize the words. Lemmatization would change words like conversation to converse, that kind of thing. And we could also remove stop words if we were interested in doing that. But for now, we'll leave it like that. Now I want to actually go into the meat of the video. We're going to try counting occurrences of each token. So I'm going to use the collections.counter class for that. And what we need to do is split the tokens. So I'm going to create a variable called trial tokens, and I'm going to take the pre-processed text I got back here, and I'm going to split on the space, and from that we can then do a count, instantiate a counter on those tokens. So what that will do is, this will be an array of individual words, and then we do a counter over that array. It will give us back the counts. So if I look at that, we get a lot of keys being the words, the values being the number of times, the frequency of their occurrences. As you know, the counter has a most common function, so we can take a look at the 10 most common words. We see that they're all stop words as we expect. So just to mitigate that a little bit, I'm going to write a line here which filters down trial tokens, and it's going to be, so for t in trial tokens, I want to filter out, I want to get back t, but I want to filter out all tokens that have length less than 4, so less than 4 or equal to 4. So let me just say that again. So what this is a list comprehension, and it's saying for each one of these tokens that we have, filter out all the tokens that have a small length of 4 or less. Only keep tokens that have 5 characters or more is a better way to put that, sorry. So that gives us back a bit more, you know, these are the words that have more than 4 characters, and we can then get a sort of better idea of, not all of these will be stop words, for example, so we filtered out some of the stop words. Okay, now what can we do with that? So I want to look at the most frequent words of lengths 5 to 20. So what does that mean? Let me define a list, and I'm going to say I want to look at each word length between 5 and 50. So starting at 5 and going up to a 20 character word, I'm going to iterate over each of these word lengths. So that will give us just, if I just look at that, it will give us a number. Oops. Just add an S to that. That will give us the numbers from 5 to 19. So what I'm going to do is, for each of those words, I'm going to look at the counts that we've got up here. Let me just remind everyone what counts is. Counts is a mapping of each word to the number of times it occurs. Okay, so it's a dictionary, it's a counter object that maps the word to the number of times it occurs. So for key and value in counts.items, what I want to do there is I want to create a dictionary mapping key value for key and value in counts.items if the length of the value is equal to the value we're currently iterating over. So from 5 to 20, I want to get, for example, all words that have length 5 in the first instance, and that will give us these words back. So that will contain, over the first iteration, that will contain all words that have length of 5 characters. Okay, and then to get the most frequent of those 5 character words, what I want to do is use the sorted function, and I'm going to call that on words.items, and I'm passing this a key. So words.items returns a tuple with the key and the value. I want to get the value, so I'm going to get the second element in that tuple, and I want to reverse that to get the most frequent word first. So if I print most frequent, I'll just break out of this so that we can see. Oops, and my bad, I think that's the length of the key. So sorry, the key in counts is equal to the word itself. So we're taking the length of the word, not the value. The value is just an integer. So that gives us the most frequent words of length 5 in this example. So if we have, if most frequent has elements, right? So we're going to check if the length of that is, we can just say is greater than 0. What we can do is append to frequent words the first value, the most frequent value, and then I can print that out down below. And what I'm going to do is get rid of this print statement, and that gives us the most frequent word that occurs for each length where there is a word between lengths 5 and 19. So this is basically saying that the most frequent word with 5 characters is would, and that's the count. With 6 is lawyer, and so on down to cross-examinations, which apparently is 1 word. So that is a way to do that, and basically what, you know, to reiterate what that's doing, we're looking at each length between 5 and 19. We're getting a dictionary with all the words of the given length when we iterate over each length. We're sorting that dictionary of words by the value, starting from the one with the most values for each of the lengths, and then we take the the most frequent by indexing into that at 0 and appending that to the frequent words. So that's how you do that. I'm now going to go on to do some more advanced stuff using Python's data science libraries, and here's a few imports that I'm going to use, and I'm going to create what's called a pandas data frame, and I'm going to create that from the dictionary that we got above of counts. Remember, that's the counter object, and I'm going to orient that by the index and columns equals count. And if I look at the data frame, we get this data frame back where we have all the words as part of the index, and the counts are the values. So that gives us a tabular structure. Simple as that. So you can look at the head of the data frame. What we're going to do is print the sum of the counts first of all. So I can say data frame count. We're indexing into that column, and we can say get me the sum of that. That gives us the total number of tokens in the trial after we've removed all tokens that are 4 characters or less. Remember, if we keep all them around, this would be more. Now I want to grab the top 20 tokens. So what I'm going to do is use the data frame's sort values function. We're sorting on the count column, this one here. I want to sort that, and I want to reverse order the sort, so that'll give me the top 20. Well, it won't give me the top 20, that'll give me all the words in order of the most frequent first. To get the top 20, I can use the pandas.iloc function and get the top 20 like that. So that gives me the top 20 words, the most frequent words in the trial after we remove the smaller character ones. And then pandas data frames can be plotted very easily, and I want to make a bar plot in Matplotlib, and I can pass any number of keyword arguments to configure that plot. So I'll set the bar's width to 0.9, and the figure size can be that. So that plots that out for us. We can see each word, the top 20 most frequent words, and we can see kind of a bar chart view on how frequently those words occur. And just to show you a cool trick in Matplotlib, we can set the rotation of the x-ticks to 45 degrees, and that will rotate that so that that's slightly more readable, and you can see which bar corresponds to which word quite easily. And I think that's all for this video. That's a basic way to do some plotting in Python. We can use the pandas data frame, and we can simply call a .plot function to the existing data frame, and we can pass a kind of plot. In this case, we've got a bar plot. You can do scatter plots, you can do line charts, you can do anything, step plots. There's all sorts of different plots available in Matplotlib, and we can configure that with things like fig size. I'll just show you a couple more examples. We can set the title, so that would be word frequencies and Kafka, the trial. This will show up as a title above the figure here, so that shows up there. So there's all sorts of things we can do here. We can even do a horizontal bar plot like this, where the bars are actually over the horizontal axis. So that's all for this video. There's so much more you can do with plotting and with analysing word distributions, histograms, and all that kind of thing. If there's any interest in any of that stuff, please let me know, and I will make videos on that. Until next time, thanks for watching.